Number 1. Based on the information in the bar graph, which statement is true? A, exactly 3 of all the bicycles are red. B, fewer than half of all the bicycles are red. C, exactly 2 of all the bicycles are yellow. Or 3, more than half of all the bicycles are yellow. So, A, exactly 3 of all the bicycles are red. Let's go to our x-axis and find red. Go to y and find 3. Are exactly 3 of them red? No, because it goes over and touches the 4 line. So A is not true. B, fewer than half of all the bicycles are red. Well, if red has 4 and blue and yellow have less, then how can fewer than half of all of them be red? They can't, so that's not true. C, exactly 2 of all the bicycles are yellow. So let's go to our x-axis, find yellow, and go up the y-axis, and it says that it is 2. So exactly 2 of all the bicycles are yellow. That is true. Let's see if D is true. More than half of all the bicycles are yellow. Well, we already said that more than half of all the bicycles are red. So how can it be yellow? So C is the correct answer. Number 2. 4 students have savings accounts. Every month, the students add the same number of dollars into their savings account as the month before. The table below shows the total amount of money each student has at the end of each month. If the students continue saving the same number of dollars each month, who will have the least amount of money at the end of month 6? I just said 2 key words in there. The least amount of money at the end of month 6. It's very important to look at those things because we're looking for the smallest amount of money at the end of this month 6. These only go to month 3, so we have to do a chart and continue it for month 4, month 5, and month 6. So let's go ahead and continue our chart. So we are going to go to, or table, I'm sorry, 4, 5, and 6. Okay, so on your test, feel free to draw just like this so it helps you see better, except don't make your lines as sloppy as mine are. Okay, so now we need to find our pattern. Kelly's pattern goes from 48 to 51. So number 1, is that going up or down? It's going up. 51 to 54 is going up. Also, the question told you that she's saving, so you know her money's going up. How much do I need to add to 48 to get to 51? 3. How much do I need to add to get from 51 to 54? 3. So Kelly's pattern is to add 3. 54 plus 3 is 57, plus 3, 60, plus 3 is 63. So it's at the end of 6 months, Kelly has saved $63. Now let's do Sean. Sean went from 44 to 48, 48 to 52. How much is he going up by? $4. So make sure that you mark this down so you don't ever forget the pattern. 52 plus 4 is 56. 56 plus 4 is 60. 60 plus 4 is 64. As of right now, who is saving the least amount of money? Kelly or Sean? Kelly. Because Kelly's total is 63, Sean's is 64. Let's do number Jack. 42 plus 48. 42 to 48 is plus what? 6. Then 48 to 54 is plus 6. So 54 plus 6 is 60. 60 plus 6, 66. And then what is the last one going to be? 72. Last but not least, Emily goes from 45 to 50, 50 to 55. What is her pattern? Add 5. So what's 55 plus 5? 60. 60 plus 5? 65. 5 plus 65 is 70. So looking at month 6, who has saved the least amount of money? Kelly. So your answer is A, Kelly. Number 3. Francine and her friends clean the park each week. The bar graph below shows the number of bags of garbage they have collected the past 4 weeks. Based on the data, how many bags of garbage will Francine and her friends most likely pick up in week 5? So, week 1, our x-axis tells us it's 18 bags of garbage. Week 2, collected, it's between 14 and 16. What does that mean? It's 15. So we went from 18 to 15. Wonder if there's a pattern here. Week 3 collected 12. So I went from 18 to 15 to 12. Is there a pattern there? Minus 3. Let's see if it continues. So we had week 3, which was 12, to week 4, which is in the middle, 8 and 10, 9. So 12 to 9 is what? 12 subtracted, 12 minus 9 is 3. So our pattern is minus 3. So if we had a week 5 up here, and our pattern was minus 3, how many bags of garbage would they pick up if they picked up 9 the last week, following our pattern of minus 3? A, 6 bags. Number 4 and 5. The data represents the length of a selection of erasers in fractions of an inch. Represent the following data in a line plot. So, your smallest number of data is going to go here. Your largest number of data is going to go here. I want you to try to plot these on the line plot, and you may click continue on the video once you are done. This is what your line plot should look like. If you transfer the data and put them onto the line plot, you would have what is here. So that's all you have to do for number 4. Now, if you wanted to give it a title, you could write that your title is erasers in fractions of an inch. And if you wanted to give it a label, you could say that X equaled the length of the pencils. So now what they want you to do for number 5 is if you were to line them up side to side, how long would your erasers be? What do you have to do next? Add them all up. So you have 1/4 plus, how many 2/4 do you have? 2 of them. So you do 1/4 plus 2/4 plus 2/4 plus how many 3/4? 3 of them. So 3/4 plus 3/4 plus 3/4. And how many 4/4 do you have? 1. Now, what did I tell you about what to do if your denominator is the same? You can just leave it as is. You don't need to touch it. But what do you need to add? The numerators. So let's go ahead. 2 plus 1 is 3. 2 plus 3 is 5. Plus 3 plus 3 is 6. This has no one to add it to, so you can just bring it down. 6 plus 4 is 10. Plus 5 plus 3 is 8. So what's 8 plus 10? 18. Are you done? No. Turn your fraction this way. So 18 goes inside the house and 4 goes outside. Now, I have 18 cupcakes. How many cupcakes can my 4 of your friends get evenly? 4, because 4 times 4 is 16. Subtract 18 minus 16 is 2. Now, can I do anything else with that 2? No. So 2 becomes my remainder. But in fractions, I don't say 4 remainder 2. I say 4 and 2 fourths of an inch. So 4 and 2 fourths inches. Number 6. The science class has a collection of bugs. The line plot displays the bug lengths in the collection. Which statement is true according to the line plot? A, there are 3 bugs in the collection that measure 1/8 of an inch. B, very few of the bugs are 7/8 inches long. C, 6 of the bugs are 5/8 inches long. Or D, 2 of the bugs are 3/8 inches long. Let's check A. If we go to 1/8 of an inch, we can see how much data is there. None. So how many bugs do we have? 0. But A says there are 3 bugs. So is that true? No. Cross it out. B, very few bugs are 7/8 inches long. 7/8 inches long has 4. Do you think that's true? No, because there's only 1 here, only 2, 1, 2, 0, 0. So a good amount of the bugs are 7/8 inches long. So that's not true. C, 6 of the bugs are 5/8 of an inch long. So let's go to 5/8 and let's count. 1, 2, 3, 4, 5, 6. Ooh, let's check D, but that might be our answer. 2 of the bugs are 3/8 inches long. Well, if you go over here, you can see that there's only 1. So the answer is C. Last but not least, number 7. Lisa's pencils wear down 1/8 of an inch each day. If she uses her longest pencil each day, how many days will her longest pencil be the same length as her shortest pencil? So you need to look at the data, but you also need to look at the line plot and the data, but you need to make sure that there is data, or x's in this case, at your longest point. So according to the line plot, the longest point is 8/8 of an inch because there's data here. So this would be your longest inch, 8/8. So following to make sure that it's on the line plot and it has data, which one is the shortest? 1/8 of an inch. Why can't it be 0? Because there's not an X here. There's no data here showing that there was any pencil that wore down 0/8 of an inch each day. So you need to figure out the difference of 8/8 and 1/8. I told you that denominators that are the same don't need to be touched. So you're basically doing 8 minus 1, or how many days you can count backwards. So you could go 1, 2, 3, 4, 5, 6, 7. Or you could do 8 minus 1, which gets you 7. So how many days? 7 days.